we were expecting that there should be 3 factors, because we know theoretically that these 10 items represent 3 factors, but when we did EFA, we got only 2. So how should we actually test our theory that, well, there should be 3 factors that should be reported by these 10 items. So what is it that we should do? We should go to the factor extraction method. Okay, we go to the extraction method and we should tell the software that we expect that there should be 3 dimensions in this 3 dimensions measured by this set of 10 items. So I am going to code, I'm going to tell the software how many factors should the software extract. So I'm going to do continue. Rotation, I'm going to keep it default, complement for oblique. Okay, and nothing else to change here. Okay, so I'm going to continue and I'm going to paste my this thing, and I'm going to say that this is again EFA with 3 factors. Okay, now when we run this, okay, now when we run this, we can see what happens to our output. So we get now, this is the communality. So the communalities look fine. There is no problem with communality. Now we see that there are 3 factors. The total variance explained by the 3 factors is 67%. The 3 eigenvalues are these. This is the scree plot. This is okay. Factor matrix. What is important for us to see is the structure matrix. Now, when I say that there should be 3 factors, so I get TO 1, 2, 3, 4 loading onto factor 1, EMP 1, 2, 3 loading onto factor 2, and I get, sorry, this is structure, sorry, I am sorry, pattern matrix. So I see that TO 1, 2, 3, 4 loads onto factor 1, then EMP 1, 2, 3 load onto factor 2, and LEX 1, 2, 3 they load onto factor number 3. LEX 3 has a little less loading, but it is okay. It is 0.49, close to 0.50, what we were saying. So I will still consider it to be, and it is not loading significantly on other factors, factor 1 or 2. So I can actually see that when I tell that there should be, I am actually getting a very good factor structure as I was expecting. Very much what I was expecting. This is what theoretically also I had written: LEX 1, 2, 3, EMP 1, 2, 3, and TO 1, 2, 3, 4. So this is my dimension 1, the second dimension, and the third dimension. When I report the factor correlation, I do see that they are correlated, which is okay. That is what I was also expecting, and that is the reason we had done oblique rotation, and the factor correlations are these. Okay, this is just the reporting in a 3-dimensional space now, because we have 3 factors. So it is not very easily visible now, because now we are looking at a 3-dimensional space, but however, it is just showing the loadings on the 3 axis, factor 1, 2, and 3 of these 10 items. So this is another way. So this is how, if you thought theoretically, because you are the person who has developed the instrument, you are the individual who knows how many factors I should expect. And this is another way that you can ask the software to report the kind of uh, to actually give or input the number of factors that you expect to be extracted.